The deepest hole in the world is so deep that it can't be seen with our satellites. It extends more than 12 kilometers below Earth's surface, which makes it nearly twice as deep as the Mariana Trench. But there are still depths below this record-breaking hole that we know even less about than the bottom of the ocean, at least for now. In fact, scientists recently proposed an ambitious plan to drill an even deeper hole than that. So here's how deep can we really drill, and why do we want to go deeper? There are two ways we can measure the depths of Earth's features. We can measure from the surface of the ground down to the center of the planet. That gives us Earth's radius. Or we can measure from the top of a mountain or the ocean floor up to the surface. That gives us Earth's topography. And both measurements tell us different things. Earth's average radius is just under 6,400 kilometers. And as far as we can tell, everything is made out of stuff. The deepest hole we've ever dug only reaches about 1/7 of the way towards the center of the planet. So what's down there? Well, not much that we've actually been able to study because the materials that make up the Earth's core are very hard to access. The deepest hole was created by a Russian drilling project called Entrance to Hell. It began in 1970 in northwest Russia and took 8 years to complete. The goal was to drill past through the Earth's crust and into the mantle, the layer of rock between the crust and the core. But after reaching a depth of just over 12 kilometers, the project stopped due to budget constraints. What they found was unexpected. At first, they hit solid rock. Then around 8 kilometers deep, they reached a layer of partially molten rock called magma. By 10 kilometers, they were passing through hotter and hotter rock at a rate of 100 degrees Celsius per meter. By the time they hit 12 kilometers, the temperature had reached 180 degrees Celsius. They also found that the pressure was intense enough to turn water to vapor. These conditions are so extreme that no human could survive them, let alone any electronics we would need to keep drilling. But the reason for going through all this trouble was to see what was there. Researchers expected to find ancient rocks that were billions of years old and might help us better understand the formation of our planet. Instead, they found rocks that were only about 200 million years old. These young rocks indicate that something deep inside the Earth is churning around and recycling old material from the mantle up into the crust and vice versa. Scientists continue to study samples from the hole to learn more about this process. And although we're nowhere near the center of the Earth, researchers say that studying these extreme environments helps us learn about places like the centers of planets and moons, as well as other worlds beyond Earth. But if measuring the depths from the surface to the center of the Earth is impossible, then what does the deepest hole actually mean? It means we're still missing a lot of information about the structure of our own planet. It turns out that some places on Earth's surface sit thousands of kilometers above where the planet's insides would end and outer space would begin. And there's nothing above those points but empty space. Meanwhile, other places on the surface are sitting on top of miles upon miles of rock. To figure out just how deep these different spots go, scientists use seismic waves. Seismic waves are waves of energy that travel through the Earth, similar to how tsunami waves travel through the oceans. Seismic waves are generated by natural phenomena like earthquakes or by humans, like when we set off explosives to survey the subsurface. As these waves travel through the Earth, they pass through different materials and reflect and refract, depending on the speed of the wave and the density and composition of the material. Geophysicists can use this information to map the interior of the Earth and reveal its hidden layers and structures. For example, in 2022, scientists analyzed seismic data from Central Europe and found that the region is sitting on top of a huge low-density zone that's about 300 kilometers below the surface. This discovery suggests that Central Europe is actually underlain by an ancient root of the Eurasian continent that has remained largely intact for the last 2 billion years. In addition to revealing structures beneath our feet, seismic waves can tell us how deep various features extend below the surface. For example, we use them to map the Moho, which is the boundary between the Earth's crust and the mantle. Seismic waves travel faster in the mantle than in the crust, so there's a clear break in the data when the waves hit the Moho. Using this method, Scientists have mapped the Moho in great detail all over the world. And it turns out that the boundary isn't as simple as we thought. The crust varies in thickness from place to place. Beneath the continents, the crust is typically 30 to 50 kilometers thick, but it can be as thick as 70 kilometers beneath mountain ranges. Beneath the oceans, the crust is only about 5 to 10 kilometers thick. But the Moho isn't the only feature we can detect with seismic waves. Since seismic waves come in all different types, scientists can also map the boundaries between different layers within the crust and the mantle. In this way, they've identified tall, thin columns of cooler rock called keels, extending from the bottom of the crust into the uppermost part of the mantle. These keels are left behind when ancient tectonic plates collide and one gets pushed under the other. So even though we haven't directly observed anything deeper than about 12 kilometers below the surface, seismic studies suggest that we can actually go much deeper without reaching the end of the Earth. But what about the deepest point on Earth's surface? We generally think of this as being the bottom of the Mariana Trench, which reaches nearly 11 kilometers below sea level. But while the trench itself is extremely deep, the seafloor doesn't actually extend much further down. In fact, the Challenger Deep, the lowest point in the Mariana Trench, is only about 6.8 kilometers below the surrounding seafloor. That's because the ocean floor is made up of huge slabs of rock called oceanic crust, and the oceanic crust doesn't extend much below the base of the Mariana Trench. In fact, the oceanic crust is only about 7 kilometers thick across most of the ocean basins. It gets thinner beneath mid-ocean ridges where new crust is formed as tectonic plates move apart and magma wells up from the mantle and cools. It also gets thicker beneath ocean trenches where tectonic plates collide and the ocean floor gets scraped off and pushed down into the mantle. Despite being relatively thin, the ocean floor plays a big role in life on Earth. It's home to a wide variety of marine organisms, including many that we don't know about yet. It also plays a major role in regulating Earth's climate and in controlling the chemistry of the atmosphere. And although we can't drill down to study the ocean floor, we can send down remotely operated vehicles, submersibles, and landers to explore the depths. But what about exploring even deeper? There are places in the ocean where the seafloor drops off sharply into giant trenches and then levels off. Here, the oceanic crust ends abruptly, and there's a flat, featureless plain extending more than 100 kilometers horizontally and down to 500 kilometers deep. These ultra-deep regions are called the sixth layer of the Earth's interior, and they're as mysterious as the center of the Earth because we have never drilled into them. While seismic waves can reveal a lot about the structure of the Earth's interior, they can't tell us about the composition of these layers. And that's why scientists are eager to start drilling again. One proposal calls for a giant international collaboration to drill a hole nearly 10 kilometers deep and 10 kilometers below the surface of the ocean. That would take us deeper than we've ever been before and allow us to study materials that have never before been accessible. In fact, there's so much that we do not know about the ocean floor and the layers beneath it that scientists are fairly certain we'll find lots of new minerals, rocks, and perhaps even signs of past or even present life. So maybe someday soon, we won't be limited to only the information we can gather from the surface. We'll be able to see for ourselves what lies in the mysterious depths below our feet and beneath the oceans. And thanks for watching this episode. If you would like to see more videos like this, please subscribe.